So, welcome once again to our discussion on dynamic panel data model. And in our last couple of sessions, we were basically discussing the empirical estimation of several dynamic panel data models, taking the data from original Arellano and Bourne's data, which was in the context of UK, and the context was the dependent variable was firm's employment. That means we were basically trying to understand the determinants of firm's employment, considering the fact that employment depends on its previous year's employment because of the reasons we have already explained, that the cost of hiring and firing. So that means tth period employment but by the ith firm depends on the t minus 1th period's employment by the same ith firm. So mathematically, if we write, then the model will look like yit equals to rho yi t minus 1 plus beta xit plus the unobserved individual specific time constant effect plus the standard idiosyncratic error. And then we started with Anderson and Hessio's approach, that was basically yit minus yit minus 1, taking the first difference, equals to rho yi t minus 1 minus yi t minus 2 plus beta xi t minus xi t minus 1 plus vi t minus vi t minus 1. And then we say that basically in Anderson and Hessio's approach, we need to use IV for this variable yit minus 1, and there are two IVs that we are discussing, either lag of level yit minus 2 or delta yit minus 2. So, if we take yit minus 2, that is called the difference GMM, and when we consider delta yi2, that is called system GMM. We have already explained in our previous sessions what exactly we mean by difference and system GMM. So, quickly what we will do, we will estimate these two models once again. Why we are doing this Arellano and Bourne's difference and system GMM? So, Arellano and Bourne's model, basically we were discussing Arellano and Bourne 1991 model we are discussing, which is basically a difference GMM model. Difference GMM based on this idea, right? Based on this idea of Anderson and Hessio, we will difference the equation and then you use lag of level for the instrument for the differenced equation. That is why it is called differenced GMM. And if we take lag of the differenced, that means delta yi2, and consider both the level equation and the difference equation as a system of equation, that is called a system GMM equation. So, one advantage is with this difference GMM, when we are taking lag of level, we will get little more observation, because delta yit means at least your observation will start from 4th period, whereas here in yit minus 2, in your instrument matrix, your first observation for instrument you will get for the 3rd period. So, 1 period also matters when your panel size is really small. So, that was the context, and I will once again estimate this Arellano-Bourne's model before we go to our next model that we are going to discuss today. So, as you know that when you use Arellano-Bourne's original data of this UK firms, 140 firms data we have, and to access the data we need to use AB data, and then once you put that, the command is xtabond. So, xtabond, then our dependent variable which is in employment, and then we have, after this what we need to do, we need to take lag of several variables, and we are taking wage and capital. So, these two are my exogenous variable. We are taking dot so we consider only lag of the dependent variable. That means lag of employment is the only endogenous variable, and wage and capital, they both are exogenous variables in this setup. And then we are taking year 1979 to 1984, right? And then we are taking year also as a separate variable of explanation, and then we are putting VCE robust command. So, this is basically Arellano-Bonds 1991, the difference GMM model that we are estimating. So, this command basically says that the moment you put xtabond, automatically it will consider that I am going to treat only in as my endogenous variable, no need of putting its lag variable. So, it will automatically take one lag, right? If we want more lag, then only we need to specify. So, we are considering our model as YIT equals to YIT minus 1. So, the inbuilt command of xtabond will consider, please keep in mind, in as the only endogenous variable, and it will consider only 1 year lag. That is all. Then after that, we are putting, what does this L0 by 2 means? That means I am considering W and K as exogenous variable, and I am considering 2 years lags of both the variables. That means WL1 and WL2, KL1, KL2, where L indicates lag of 1. And then these are my year dummies. This is my year, and this is I am taking the robust standard error. Sorry, I have to put year over here. I have missed year. So, I will put the command once again. So, this is year 1984, and if you put that, then you will see the Arellano-Bonds estimates. So, it is coming 0.62 in the difference GMM model, and it should lie between 0.73 to 1.01. But as you know, in this model, I have included only W and K. I am not including the WS, and then I asked to take it as an assignment to see after inclusion of all the variables whether this NL1 coefficient is lying within the interval or not, because if you recall previously when we first estimated FE and OLS, we have included WSL1 and YSL2. That means industrial output we took as a proxy for aggregate demand, right, in that particular year. So, if you include those variables, whether your coefficient is changing or not. So, this is basically in short Arellano-Bonds 1991 model we have estimated, and we have 40 instruments over here, and we have also explained that out of these 40 instruments, 12 we are getting from the Arellano-Bonds 12 we are getting from the standard instruments from the exogenous variable, and if you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So, 12 standard type instruments and 28 instruments are coming from that endogenous variable from the third periods onwards. If you consider, if you relook once again the instrument matrix in Arellano-Bonds approach, 1991 approach, you see that in the third period I have one instrument, fourth period 2, fifth period 3, likewise it will go on, and if you add all these instruments you will get 28 instruments totally. So, 28 instruments are GMM type and 12 instruments are standard type, total 40 instruments that we were getting in Arellano-Bonds difference GMM. But we explained that in difference GMM it has a shortcoming because we are using lag of level YIT minus 2 as an instrument for variables which are in differenced form. So, lag of level are of poor instruments type for differenced variable, right, and the severity of this problem increases when the variables are actually variables they follow a random walk. To overcome that problem, Arellano and Bover, we said that Arellano and Bover 1995 and Blundell and Bond 1998, they basically suggested system GMM. So, this is Arellano-Bond difference GMM. Here the problem is, as we have already mentioned, that lag of level. What is the problem? Lag of level acts as poor proxy for poor IV for variables which are in differenced form. So, to overcome this, Arellano and Bover and Bover 1995 and Blundell and Bond 1998, they suggested system GMM. So, what is system GMM? Basically, lag of difference variable delta yi t minus 2 as instrument. Okay. So, instead of taking lag of level, I am taking lag of the differenced variable, right. So, this in this approach I am considering level equation as well as different equation as a system of equation. Lag of level acts as instrument for the difference equation and lag of difference act as my instrument for the level equation, right. So, once again with the same variable, if we use system GMM, then to use to estimate system GMM, the command what to use is xtdpd sys. xtdpd is for dynamic panel data model and sys for system GMM. So, totally xtdpd sys, and then we have the same command, the whatever we have used earlier. So, that means I can put this part of my command here. So, xtdpd sys, then my dependent variable, then twice lag of w and k, and then here again I should mention here and then if you put then you will get this is the estimates of system GMM, and this estimates of system GMM, as you can see, this coefficient is 0.82, which is fantastic because it is lying within the FE and OLS estimates as we have discussed previously. But we have also mentioned that there is a warning or cost for this system GMM because it puts additional restriction about the initial condition of the data generating process for YIT. Why this is so? Earlier we were putting YIT minus 2 as instrument. That means the orthogonality condition is that expectation of this as an instrument. When you are saying this as an instrument, that means expectation of YIT minus 2 and the covariance or the error term is 0. So, this is basically the moment you put this orthogonality condition, it is something like I am specifying a specific data generating process for YIT, please keep in mind. So, this when I am putting only one such instrument which is coming from the YIT minus 2, that means I am putting only one type of restriction about the initial condition about the data generating process of YIT. Now, in system GMM what is happening? I am considering YIT minus 2 as well as delta YIT minus 2. So, I am taking YIT minus 2 as well as instrument. Okay. So, earlier it was only YIT minus 2, now it is this plus this. So, orthogonality conditions about this and this, that means I am putting additional restrictions about the initial process of the data generating, initial condition about the data generating process of YIT, that is all. So, putting additional restrictions comes with some kind of cost, and that is the cost of system GMM we have mentioned in our previous class. And we ended our class saying that once we estimate dynamic panel data model, basically we need to go for two type of post estimation checkup. Okay, two post estimation checkup. For DPD, dynamic panel data model. What are those? First one is there should be autocorrelation of order 1, because the structure of the dynamic panel data model itself says, since we have introduced lag of the dependent variable in the model, AR1, that means autocorrelation of degree 1 is inevitable. We must get that. If we do not get it, that means the presence of YIT minus 1 is unnecessary. So, we are undermining the dynamism in the system. So, AR1 must be there by construction of the model but AR2 and higher should not be there, and higher, that means let us say ARP should not be there. right. So, this is basically the first post estimation checkup regarding the presence of higher order autocorrelation is there or not, that we have to test. And second one is, since there are too many instruments used in the estimation of a dynamic panel data model, we must check over identifying restrictions should be valid for each of the instruments. So, these are the two post estimation checkup. We will start with the first one, whether autocorrelation of higher order is maintained or not. So, the command for this, once we estimate this, we can use estat command, estat, estat abound, and then we have to put a comma, AR test. Here I am putting up to 4th order autocorrelation, okay, AR test 4. Now look at what is happening. Look at the Z coefficient, minus 4.64 and the probability is 0.0000, the p value. So, that means first order autocorrelation is there, but none of the higher order autocorrelation coefficients are significant here. That is what this particular result shows. My null hypothesis is no autocorrelation. So, I can reject my null hypothesis only for year 1, which indicates the presence of first order autocorrelation, but null hypothesis of no autocorrelation cannot be rejected for second, third and fourth order autocorrelation. Okay. So, that means what we can say, that the result indicate the results indicate the presence of year 1, but not year 2, year 3 and year 4. Okay. That is the result. Now, we should check for the second post estimation checkup, which is whether over identifying restrictions are valid for each of these instruments. Now, to test that condition post estimation, to go for that second post estimation checkup, we need to estimate the dynamic panel data model using another command, xtabound2, developed by David Rudman. So, what I am saying, we can estimate the same difference and system GMM models by using xtabound2, xtabound2. And what was the command used for this autocorrelation? I will mention that also. Estat abound, comma, AR test 4. I was taking up to 4th order lag. This was the command.